So in this video we're going to try and find the area of a triangle with 3 different techniques. Now the technique we're going to use today involves coordinate geometry. So I've got a triangle here. Now it's a scalene triangle, all the sides are different, but I've got the coordinates written out for each point. So I'm going to call this point here A, this one B, and this one C. Okay, so the 3 methods for the area of a triangle. Well, the most popular one is Herons Formula. So I'm going to write that one up here, Herons Formula. Now, this formula is in 2 stages. So we've got our variable S. What it is the sum of 3 sides. So A plus B plus C, and then divided by 2. So on this triangle here, we could put this as A, this is B, and this is our C. So sum these sides up. When you know the length, divided by 2, that gives us a variable S. And then our area is square root of S times S minus A, S minus B, and S minus C. That's our generic formula for the area of a triangle using Herons Formula. Okay, now there's another one, another formula we can use, and that's the trapezoid formula. So the trapezoid formula. So this one is a summation formula. Now this one it gives us double the area, so at the end the number we get we have to divide it by 2, and that is the sum of I equals 1 to n, where n is the number of sides, so a triangle n would be 3, and we have y subscript I plus y subscript I plus 1, and then we multiply that with x subscript I, and then we subtract that from x subscript I plus 1. So that's another formula. Now this here involves y subscript 1, 2 and 3. So here we need to assign our x1, 2 and 3. So here let's use our A. So that equals 1, 0. Our B equals 5, 7, and our C equals 7 minus 1. So that can be our x1, our x2 and our x3. And here we've got our y1, y2 and y3. And we can find those accordingly using this formula. Then the other formula is Shoelace formula. So this one involves a series of matrices. Now the Shoelace formula, you'll see why it's got that particular name in a moment, but it's also a formula which was developed by Frederick Gauss. So it's also called Gauss's area formula. So Gauss's area formula. And it involves calculating the determinant of 3 triangles. So just a quick run through on the determinant. So our determinant of a matrice, so that is AD minus BC, where we set up our matrice like this, A, B, C, D. Okay, so AD minus B times C. So you see some sort of crisscross pattern going on there. So this one again gives us twice the area, so our result we have to subtract, so we have to divide by 2. That equals the determinant of x1, y1 and x2, y2. So again using these values of these points here, and then we add that to another determinant of another matrice. So that'll be x2, y2, x3, y3, and then add that again to now x3, y3, and this time we can't do x4, y4, obviously there's only 3 sides, so we use this x1, y1. So now you can see why this is called the shoelace formula, and everything is intertwined just like shoelaces. And here we need the absolute value. So whatever the sum of that is, you need the absolute value. So if that comes out as a minus, then obviously we take the absolute value and then divide by 2. Okay, so let's calculate one of these first. So let's have a look at this trapezoid formula first. So 2a equals the sum of these calculations here. So let's work that out. So I equals 1 to n. Well, n is 3 in the case of a triangle. So now we've got, so if I equals 1, we've got y1 plus y2. So y1 is 0 and y2 is 7. So we've got 0 plus 7 multiplied by x1 minus x2. So x1 minus x2, so that's 1 minus 5. Okay, and then because it's a summation formula, now go on to I equals 2. So we then add that one up. So now we've got y2 plus y3. So that's 7 plus minus 1. Multiply that by x2 minus x3. So that's 5 minus 7. Okay, and then we add this. Let's bring this one down here. So now we add this to with y equals 3. So that's y3 plus, well, it would be y4, but there's no y4. So we then use y1. So y3 is minus 1. And then y1 is 0. And then with the x's, we have x3, that's 7, and then minus, we then use the 1, so 7 minus 1. Okay, let's work this out. So 0 plus 7, that gives me 7. 1 minus 5 gives me minus 4. 7 plus minus 1 is 6. 5 minus 7 is minus 2. Minus 1 plus 0, minus 1, 7 minus 1, 6. Okay, so now we've got 7 times minus 4, which is minus 28. 6 times minus 2, which is minus 12. So now I can just subtract another 12. And minus 1 times 6, that gives me minus 6. Okay, so add these up. Minus 28, minus 12, minus 6. That gives me minus 46. But I need the absolute value. So if I take the absolute value of that, that equals 46. So my 2a equals 46. So if 2a equals 46, then my area by this formula, that equals 23. Okay, so I'm just going to write this up on this board here. So by the trapezoid formula, our area equals 23. So that takes care of that. So let's clear this off the board and we'll have a look at Gauss's area formula. Okay, let's have a look at Gauss's area formula. So now, x1, x2, y1, y2. Let's put those values in. So x1, x2, that gives me 1 and 5. y1, y2 is 0 and 7. So determinant of that. And now x2, x3, that's 5 and 7. And y2, y3, that's 7 and minus 1. And determinant of that. And now let's have a look at this one, x3 and x1, so that's 7 and 1. And y3, y1, that's minus 1 and 0. Okay, so we've got our determinant formula here. So let's go through that. So AD, so that's 7 minus 5 times 0, that's 0. 5 times minus 1, that's minus 5, minus 7 sevens, 49. So that's what we got there. And then this one here, 7 times 0 is 0. Minus 1 times 1 is minus 1. So minus minus 1. Okay, let's just go through these. So now we've got 7 plus minus 5 minus 49 is minus 54. So this could just be a minus. And 0 minus minus 1. So that then becomes plus 1. So now we've got 8. So 7 and 1 is 8. Subtract 54. So that equals minus 46. So as before, we take the absolute value. So 2a equals the absolute value of minus 46. So now 2a now equals 46. So therefore a equals 23. Okay, so using Shoelace formula, I'll write that one over here. So Shoelace formula. We're in agreement here. Area equals 23. Okay, let's take this off the board and we'll have a look at Herons formula. Okay, Herons formula. So first of all, we need this S variable, A plus B plus C. But we don't know our values of the length of the sides. So we're going to need to work them out using our coordinates. So let's have a look at this A first. So for A, that's going to give us a triangle based on this one here. So let's go along down this line here. Okay, so using Pythagoras' theorem, we need this side and this side. So the difference in the x's from here to here, we've got 5 and a 1. So this one here, that's going to give us 4. So let's draw this triangle up on here. So this bottom side is 4. This side here is from 7 to 0, so that one is 7. So then using Pythagoras' theorem, we're going to have a square root in there of 7 squared plus 4 squared. So that's 49 plus 16, so that's square root of 65. So that gives us RA. What about B? So we got our triangle here. So if we just have a look here, we go along here, go along there, that's going to give us our triangle here. So let's have a look at that. So B equals, so let's draw the triangle. Okay, difference in the x coordinates here, we've got 5 for the B, 7 for 7 for C, so that's 2. And this one here, our y coordinates goes from minus 1 to 7, so this is a side of 8. So then we've got a square root, so the square roots is going to be our answers because it's the hypotenuse we're interested in. We've got 8 squared plus 2 squared, so that's the square root of 68. And let's have a look at our C. So this is our C. So now we need to come down here, go along here. So now we've got a triangle that looks something like this. So this one here, x coordinates go from 1 to 7. So this long side here is going to be 6. And this coordinate here goes from y is 0 to y is minus 1, so the side is 1. So now this is going to be the square root of 6 squared plus 1 squared, so that's 37. So now we've got our A, B and our C. So now we can say our S equals square root of 65 plus square root of 68 plus square root of 37 divided by 2. So that's going to be our S. So let's plug that in a calculator and see what we get. So in a calculator, I get approximately 11.1956. That's my S. Okay, so now for my area. I'm ready to just set this up now. So area, that equals square root of my S times S minus A, which is square root of 65. S minus my B, which is square root of 68. And S minus C, which is square root of 37. Okay, now plug all these into the calculator with my S being approximately 11.1956. I'm going to get exactly area equals 23. I'm going to let you plug that in to your calculators and check, but any difference, put in the comments down below. Now, looking at these three formulas, we've got the Herons formula here, which is the basic one that we always learn first. Now, this one for me looks the most complicated. Then we had the Trapezoid formula, which was the summation formula. That looked really simple to me. And then the Shoelace formula, that one there looked definitely more simple than this by quite a long way, but only slightly more complicated than this one, but very, very little. So leave your comments down below, tell me which one you prefer, and that's the way we can use these formulas. Now, one advantage that the Trapezoid formula and the Shoelace formula has is these two formulas can be used to calculate any polygon. So you can have a 4-sided shape, 5-sided shape, 6-sided shape. These formulas will work, whereas the Herons formula only works for 3-sided shapes, i.e. triangle. So for me, this Herons formula, even though it's the first one we learn, for me it's the most complicated. Okay.